So we have time 0, time 1, and time 2. Now remember that the income, the profit in the first period, were assumed to be 375, and the second income were 225. The capital invested is 600 at the beginning of the first period, time 0, and 400 at the beginning of the second period. Time 2, the capital invested is 0 because the project is over. Now, consider that we have two incomes at time 1 and time 2 respectively, and we have two capitals at time 0 and at time 1. Then what we can do is to compute the ratio of the present value of all the incomes, we can compute the present value of all the capitals. So we have a total return referred to time 0 and a total capital referred to time 0. So both total income and total capital referred to time 0. So we essentially take each income and discount it back by 1 and 2 periods respectively. The same is made with the capital. We only have the capital at time 1, which is to be discounted. So we made a note as PVI the total return referred to time 0. First income discounted by the cost of capital. We remember that we assumed 15% as the cost of capital, plus 225 divided by 1 plus 0.15. This makes 496.26. This is the total return referred to time 0. This is the present value of total return. Then we have the total capital, which is the present value of the capital is invested. We discount 400 by 50% by 1 period. And as we know, this is 947.8. Now we may divide the present value of the returns by the present value of the capitals, and then let us wonder what we have found. Now we divide the present value of all the returns by the present value of all the capitals. 496.26 divided by 947.8. This makes 0.5236, which is 52.36%. Now what is this rate of return? This is certainly a rate of return because this is a return divided by capital. But this is an instantaneous rate of return. This is an instantaneous rate of return. Because we divide a present value of returns by a present value of capitals. So it is as if the investor invested 947.8 times 0 and received at times 0 496.36. So this is an instantaneous AIRR. Instantaneous AIRR. If we want a discrete rate of return, a discrete AIRR, then we have to multiply this figure by 1 plus the cost of capital. We have to multiply by 1 plus the cost of capital, because this is the compound amount of $1 invested at time 0. Invested at time 0. So we want the value of this instantaneous rate of return after one period. We want a discrete rate of return. So we take 52.36% and multiply by 1.15. The result is exactly what we had found in the first two videos. 60.2%. And this is the discrete AIRR, which means that if the unit of time is the year, this is the annual AIRR. If it is the month, it is the monthly AIRR. So we can conclude that the AIRR may be computed as a ratio of the present value of all the returns to the present value of all the capitals multiplied by 1 plus the cost of capital. A ratio is an instantaneous rate of return. Instantaneous rate of return and this factor is a conversion factor. Is a conversion factor which converts the instantaneous rate to a discrete rate. Conversion factor. In general, if we have an end period project, the AIRR may be written as first income discounted by one period, which is the present value of the first income, plus the present value of the second income, plus the third income discounted by 3 periods. So this is the present value of the third income, and so on, until we compute the present value of the last income. And this is the present value of all the incomes, divided by the present value of all the capitals invested. And so on. The last capital invested is C of n minus 1, which is invested at the beginning of the last period, the nth period, discounted back by n minus 1. And this ratio is multiplied by 1 plus the cost of capital. So we can write the numerator can be written as the present value of all the returns divided by the present value of all the capitals multiplied by 1 plus cost of capital.